The plan for this recording, we're going to look at application problems where we have systems of equations with three variables. So that means we have to have three equations. On the screen, there is an example of a word problem, application problem, where we're going to have three equations and three variables. As we read through a word problem, we want to try to figure out a couple things. First thing is, what are my variables? What is it I'm trying to find? Most of the time, if not all the time, the variable will be what we're trying to look for. Okay? So if I read this problem, the last sentence says, not the last sentence, the question B says how many swimmers, finished in each place. That's my variables. What places? We have first, so I'll call F the number of first place finishers, and we have second place finishers. I don't like S, but I'll use S anyways. Number of second place, and we'll call T number of third place finishers. Okay, so there are my three variables. Now, as I read through this, I want to find totals. Okay, second sentence. The email states there's 24 individuals placed. Okay, 24 individual placed. That must mean that the number of people who finished first plus second plus third has to be 24. 24 people finished, so there's 24 different places. Next, the number of points earned. Well, every first finisher earns 3 points. Every second place finisher earns 2 points, and every third place finisher earns 1 point, and 53 total points were scored. Okay, I don't see any more totals in that problem. However, I do see a relationship between first, second, and third. There were as many first place finishers, F, as second and third combined. The number of first place equals the number of second and third combined. Let me rearrange that. Put it back into the same form as the rest. Second plus third combined. Okay, we have our three equations. So now we go back to our techniques for solving systems of equations. Whether we have two variables or three variables, the techniques are the same. I can use substitution, or I can use elimination, or I could use graphing, which we're not going to do in this case. We want to solve it algebraically. So I'll use substitution. Why? Because it says F equals. I know what F equals. So I can substitute that into my two equations for F, into both equations. Remember the techniques for solving a system of 3 by 3. I want to reduce my three-equation, three-variable system down to a two-equation, two-variable system, meaning I need to eliminate the same variable from both equations. By plugging in S plus T into F, the F goes away, and I now have eliminated the F in the first equation. This was F. I took out the F, I put in S plus T in its place. And it looks strange having S plus T plus S plus T. But remember, this is now the S plus T. Okay, next sentence. We have 3 times F, but F is S plus T, plus 2S plus T equals 53. Okay. Now let's rearrange this to make it a little more organized, meaning let's combine some like terms. Top equation, 1S plus another S is 2S, 1T plus another T is 2T. Next equation, I have 3s plus 3t, distributing the 3 to both terms. I have 2s plus t equals 53. Let's rearrange that some more. I have 3s plus 2s, which is 5s. And I have 4t, 3t plus 1t equals 53. I'm going to get rid of that guy. I'm going to slide the other one up. Not like that. Okay? I'm going to slide the other one. Come on. Sorry. It's not cooperating. I won't slide it up. Okay, next thing. I have two equations with the same two variables. Okay? I need to eliminate or substitute. Looking at these two, I think elimination looks easier. I will multiply the top equation by a -2. Why? So I can get my, I'll go ahead and write it. By doing that, now I have my t's to have the same coefficient but different signs. Why is that good? Because now when I add those together, I get 1s equals 5. -4s plus 5s is 1s. -4t plus 4t is 0. -48 plus 53 is 5. S equals 5. I'm going to take what S equals now and substitute it into one of these equations that I've got here. It does not matter which one. I think this guy right here in the middle looks the easiest. So I have 2 times S. S is 5. Plus 2 times T equals 24. 2 times 5 is 10. Subtract 10, I get 2t equals 14. Divide, and t equals 7. Now that I know what t equals, go back to my 3 equations at the beginning. I like this one here. This one says F equals S plus T. Well, I know S is 5. I know T is 7, so F must equal 12. Does that come out to be correct? If I plug into the top equation, I have 5 plus 7 plus 12 equals 24. Yep, the number of total swimmers is equal to 24. And if I plugged it into the other equation, we should get 53. So we have our 3 answers. Okay. Number of first place finishers is 12. Number of second place finishers is 5. Number of third place finishers is 7. Okay, let's try another one. Ignore the answers down there at the bottom. I'll just cover them up to. All right, next thing. I would hit pause and try this one. See how well you can do. Remember to look for 3 variables and 3 equations. Okay, first thing, as I read through this, get rid of that mess. If I read through this, I'm going to go ahead and scroll down. Those answers are just to some other problems on this particular worksheet. So if I look at this, I have 2 bottles of water and 1 bottle of juice that sell for $2.55. What are my variables? Well, we have water bottles and we have juice bottles and we have, if we read the next sentence, milk bottles. Are we worried about, or are we looking for the number of water bottle, juice bottles, and milk bottles? Or the cost of, the price of? Look at my question. Find the prices of each type. I'm looking for prices. I'm going to call water, or W, the cost of a water bottle. And I'll call J the cost of juice. And I'm going to call M the cost of milk. Okay? So in the first sentence then, we have 2 bottles of water, 1 bottle of juice, and the total cost was $2.55. Second equation, 2 bottles of juice plus 1 bottle of milk equals $2.45. Last sentence, 1 bottle of water plus 1 bottle of juice plus 1 deal of milk equals $2.30. I don't know these ones, sorry. Sometimes I put them in there and sometimes I didn't. Okay? So now, remember from the problem we just did, my goal is to get this 3-equation, 3-variable system down to 2 equations with 2 variables. So I need to cancel the same variable or somehow end up with 2 equations with 2 variables. What I noticed is the first 2 equations only have 2 variables. So it would make sense to use one of those equations. I'm going to use the top equation. I will call 2w plus j equals $2.55 one of my equations. So what does that mean? There's no m in that equation. So now when I look at the next 2 equations, I need to cancel m so that I have another equation that has just w's and j's. So if I look at these 2 equations, how do I cancel m? Well, I just need to subtract the 2 equations, right? So I have basically 0 w's up here. So 0 w's minus 1 w is a negative w. I have 2 j's, and I'm subtracting 1 j, and so I get j. M minus m goes away. And $2.45 minus $2.30 is 15 cents. Down to 2 equations with 2 variables. Pick the technique you like, either elimination or substitution. I'm going to keep going with elimination. If I subtract these 2 equations, I notice my j's will cancel. So I will subtract them. 2w, this is where it's hard when you subtract, be careful. 2w minus a minus w makes it 2w plus w, which is 3w. J minus j is 0. $2.55 minus 15 cents is $2.40. Divide by 3, and w equals 80 cents. Water costs 80 cents. Let's go back to the same equation, or the top equation, I guess. Now I'm going to go I'll go to the top equation. 2 times w plus juice, or j, equals $2.55. This becomes $1.60. Subtract, and we get 95 cents. Okay? Last equation. We know that, or plug this back into one of the equations. Doesn't matter which one. I need to find m. I'll go back to the bottom equation. So 80 cents plus 95 cents plus something has to be 230. Combine like terms, $1.75 plus m equals 230. Subtract, and m equals 55 cents. Solving a system of 3 by 3 is very similar to solving a system of 2 by 2s. As you read through the problem, you are now looking for 3 variables and 3 equations instead of 2 variables and 2 equations. And then just go through the process of solving and the techniques we use for solving. Okay, that is solving a 3 by 3.